Hi, my name is Stephanie Brooks, and I'll be covering food colorants in this video. Food colorants are considered dyes, pigments, or substances that can be added to food that will impart a certain color to that food product. Color is a result from reflection or the absorption of light and can be measured by the electromagnetic spectrum. Primary reasons people will add food colorants into food products is to offset the color loss due to oxidation, light, pH, storage, and processing. It is also used to produce a consistency within food products and allow consumers to identify a certain color with a certain food product. There are three major categories food colorants can be placed into. There are pigments such as natural colors, artificial colors, also known as synthetic coloring, and lakes and dyes. So pigments or natural food colors are colors that do not necessarily have to be tested by the FDA and will be listed as colors exempt from certification. Many of these sources will include seeds, fruits, bacteria, insects, and the list really just goes on. The next kind of category of food colorants can be synthetic coloring or artificial food colors and are chemically manufactured and the most commonly used by the FD&C, and there's currently 7 being used. The next two will be lakes and dyes. Lakes are made by combining dyes with salts to make insoluble compounds, and lakes will be more stable than dyes in food products because they are more easily dispersed in foods containing more fats and oils or items that lacking sufficient moisture. Dyes will be more easily dissolved in water but will not be soluble in oil foods or foods containing a lot of fat. Color pigments can be divided into 6 different categories. These categories will include tetrapyrols, isoprenoids, benzopyrens, betalains, melanoids, and caramols. Tetrapyrrole compounds will include chlorophylls and hemes. A tetrapyrrole pigment has 4 pyrrole portions joined together by a porphyrin ring. Chlorophyll is a green pigment found in most plants, algae, and cyanobacteria and is located in the chloroplast of plants. Chlorophyll is a chlorine pigment, and at the center of this chlorine ring is a magnesium ion, and they can have many different side chains that can be attached. The most common will be a long phytyl chain. In hemes, instead of this magnesium ion, there will be an iron in the center, and many hemes can be found in meat products. Chlorophyll is lipid soluble, and when they lose this long phytyl chain, it will become water soluble. Chlorophylls and hemes are affected by pH, water, light, oxygen, and enzymes. The next category of food colorants are isoprenoid derivatives, and these will include carotenoids. Carotenoids produce an orange photosynthetic pigment in many foods like sweet potatoes, melons, and dark leafy green plants like romaine lettuce and spinach. Carotenoids provide antioxidant properties within their plants, and carotenoids are polyunsaturated hydrocarbons that contain around 40 carbons per molecule. Carotenoids can be classified as carotenines, that means they contain no oxygen, or xanthophylls, that means they contain oxygen. These two isomers of carotenines differ in position of double bonds and their cyclic group at the end. Carotenoids are affected by light and air, and they're more stable under heat, and their color will depend on the presence of their double bonds. The next category of food colorants will include benzopyren derivatives, and these will include flavonoids and anthocyanins. So flavonoids are a subclass of phenolic compounds and will cause many color changes like whiteness in plant and black due to co-pigmentation, and will also contribute to the flavor. There are 2 different groups of flavonoids. There are flavonins and flavivans, and anthocyanins are in one of these subgroups. Anthocyanins are water-soluble pigments and will appear red, purple, or blue according to their pHs. They are odorless and many are flavorless and appear in tissues of plants. They act as light attenuators and as antioxidants. Their substituents hydroxyl and methoxy groups and number of double bonds are responsible for the color changes. If there's more hydroxyl groups, it'll be more bluish in shades, and if there's more methoxy groups, it'll be more red in shades. It's easily destroyed during processing and affected by oxygen presence and pH. The next food colorant will be betalains. Betalains are red and yellow indole derivative pigments and are most noticed in petals of flowers and include antioxidant properties such as those found in beets. Unlike anthocyanins, they contain nitrogen and contain aromatic indole derivatives synthesized from tyrosine. Betalains are not a flavonoid, and each betalain is a glycoside and consists of a sugar and a colored portion. The last categories of food colorants are melanoids and caramels, and they're often grouped together because they produce brownish pigments in food due to Maillard reactions. Thank you for watching, and I hope you learned something about food colorants.